Mutually exclusive.
Two events are mutually exclusive if they cannot occur at the same time.
Circle A represents the probability of A occurring. Circle B represents the probability of event B occurring. There is no intersection between the circles. Therefore, event A and event B are mutually exclusive because they cannot occur at the same time.
Examples.
Flipping a coin. Event A, the coin lands on heads. Event B, the coin lands on tails. A and B are mutually exclusive because the coin cannot land on both heads and tails at the same time. It is physically impossible. Event A, partying at a friend's house. Event B, studying at the library. Event C, sleeping at home. A, B, and C are all mutually exclusive because they cannot happen at the same time.
Cloud. Independent events.
Two events are independent if the probability of one event occurring does not depend on the probability of the other event occurring. Probability of A given B is equal to the probability of A. Test for independence. Probability of A intersection with B equals the probability of A given B times the probability of B, which also equals the probability of A multiplied by the probability of B.
Tree. Example. Untied shoes. Event A, left shoe untied. Event B, right shoe untied. Probability of A equals 0.5. Probability of B equals 0.5. Probability of A given B equals 0.25. And the probability of A times the probability of B equals 0.25. Therefore, knowing these two are equal, it can be determined that the two events are in fact independent. Fireball. Clouds.
Conditional probability.
The probability of an event when the outcome of the event may change given the outcome of another event is conditional probability, and you can use this formula. The probability of A given B is the probability of A intersection B divided by the probability of B for any B greater than 0.
Example. College students were surveyed and asked which liqueur they preferred. Whiskey, tequila, or vodka. 40% chose vodka. 35% chose whiskey.
25 chose tequila.
The students were then asked if they also liked to drink gin. 14% of those who preferred vodka also liked gin. 30% of those who preferred tequila also liked gin. And 82.5% of whiskey drinkers also liked gin.
Question. What is the probability that a random surveyed student will prefer vodka and like gin? Cloud.
The probability of preferring vodka is 0.4. The probability of liking gin, given that the student prefers vodka, is 0.14. Probability of liking gin, given that the student prefers vodka, is equal to the probability of liking gin and preferring vodka divided by the probability of preferring vodka. The probability of liking gin and preferring vodka is what we are looking for. By rearranging the equation, we get that the probability of liking gin, given that and that we prefer vodka, is equal to the probability of liking gin, given that you prefer vodka, times the probability of preferring vodka, which is equal to 0.14 times 0.4, which equals 0.056, which is the probability of liking gin and preferring vodka.